Welcome to the Game Computer Science Unit 1 IA walkthrough. This video is part of a series of 7 videos, I think, that will give you a full start to finish walkthrough of what the Computer Science Unit 1 IA is supposed to look like, giving you examples, working on the code, showing you the documentation, and giving you all the little tips and tricks in between about how you should approach your IA. So I hope you learned something, but just remember, I'm not a teacher. Whatever your teacher decides to tell you to do, follow what your teacher says. This is for people who don't have teachers, if your teacher's sick, or you're doing it on your own, right? So, enjoy! Alright, so we are back for part 2 of the coding. Yeah, when I finished yesterday, I was really trying to do all the code one time, but that didn't go too well. So this is part 2. We're going to start to code out some structures, some functions, and yeah, by the end of it, we should finish all the code. Hopefully we get in an hour. So just to remind you all of where we are, we have this document here. We finish off. We did all the pseudocode. And I left spaces for these particular functions. Say add patient, update patient, remove patient, print patient to the screen, print critical patients, right? And we coded out everything else, which is the layout of the program, the menu, displaying, and everything is working according to plan. It's displaying the menu, and whichever option we choose, it's choosing, right? So I'll just run it and you'll see on the right hand side here. It'll come up, welcome to the hospital. Right. Welcome to the hospital week here. Please enter the 4-digit passcode, which is 1111. Put that in. If you're watching this video, if you happen to see this video and you realize we're now on part 2, where do I find part 1? Then there's a whole playlist fit. Easiest way to do it is to download the app, learn IT, and you'll see all the playlists. But you could go and search the channel and look for part 1 of this, because I might link the playlist at the bottom if I feel like it. Alright, so menu options. Add patient 1. It should say that the menu option shows us 1, 2, 3, 4, 5, and 6. All of the options working. And when you press 0, it says thank you for using your program, right? So that is proving that the program is working. Now what we want to do is we want to match all the options to the function that it has to do, which is function 1. This should be add patient. Yeah, right. So let's try to do the add patient function. So if we want to add a patient, let's see what our file structure looks like. Our file structure looks like this. We're supposed to get our ID, surname, first name, age, and status, right? Okay. So I will leave the menu here blank. I'll leave the choices blank here. So the option chosen is 1. We'll leave that there, no problem. Let's do the add patient function. Alright, so to add a patient, I don't need to return anything. I could just put it as a void function because I don't need to send anything to the add patient. Nope, I'll read everything one time. So void add patient. Right. That should sort us out there. We have the add patient. What I want to do is I want to add an individual person to the end of the structure. Now as it stands, when we read all the information from the file, there is a counter here for read data, which will be the C++, right? So what I want to do is starting from 0 and going all the way up to whatever number. So from the first time I read a file, it'll be 1, 2, 3, 4, 5. So it should give me the total number of people in the file, and we proved that by printing it out, but I had to print C-1 because it's actually the last number. Takeaway 1 will be last record, right? Remember we did that in video 1. So what I want to do is at the end of this read data, I want to put in an update for actual size. Can I update a constant? No, I can't update a constant because I set actual size as 0. Sorry to interrupt the video, but this is future me talking to you while you're watching this. And if you are struggling with a certain part of your eye, or you just need somebody to check over your eye, we do personal one-on-one eye classes. So if you want your eye to get a check over, just to make sure you have all the requirements on the marks, makeITsimpleTT.com/register. Okay, cool. Back to the video. Interesting. Yeah, can I set a actual size is equal to C? That'll give my error. Yeah, I can't assign actual size to C. Let's not define actual size and let's put actual size equal to 0. Will you accept that? Yeah, cool. Alright, so now I could say actual size is equal to C here. That should be acceptable. Will I get any errors? Nope, no errors. Alright, cool. Okay. Right, so I had to define the constant of max size as 0, as 100, so that I could create this struct patient here. But I can't do that for, right, so okay. Alright, so the reason I have to change the actual size from a defined value is because I have to update the value, so I have to put it as an integer. So I'll take out the define actual size 0, and I'll just put these two global variables. One is a constant to say the size of the actual hospital, and the other one is the actual size 0, right? So when I finish read the data, the reason I'm setting actual size to C is because after I read the information from the file, I need to know where the last record is. The last record is actually at location 12. So I have to set the actual size to C-1. Well, C-1. Because how the counter will work here, go 0, it'll start off at 0, and it'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But it will count to 13, but 0 has to be considered as a number. So that's why I have to set the actual size to C-1, because that's the actual amount of things that I have inside the array. Because when I read from the file, it will read all of these. But my counter is starting with C as 0. So therefore it will count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it will count to 12, but really and truly, it's 0 to 11 in the array of structures. I hope you understand that, because that's why you have to put it as C-1. If you don't understand that, then that means you're not really grasping the concept of arrays, but arrays start at 0 all the time. So anyhow, I set the actual size to C-1. That way I know when I go into any of the functions, I could just update actual size as I go along now. So we're going to do the void add patient. We will say printf. All of this we might just fast forward. Please enter the patient, the new patient information. Alright, so we're getting new patient information, and they will put it in. So now we have to scan all the things straight into the array of structures. Because I'm lazy, I am going to take all of this here and put it in here, and just take out the F of the F scanner, because like I said, I'm lazy. Do I need to tab it? No, I don't need to indent it, because it's not part of any control structure. Please enter new patient information. So I'm just going to do scanf in. I don't have any in because it's not an input file. So I'm taking out all the scanfs in. So there's a faster way to do this, but I can't remember. I'll probably figure it out. I'll probably remember it some other time. Right. So that should read it straight into a particular variable, which is C. But my problem is that I can't read it into C because I want to read it into where actual size is. So yeah, CT actual size. Actual size. Alright, this is the actual size of the array. Okay, Now I have a choice here. I could do actual size plus plus before we start. So I'll basically carry the actual size will end up being the real amount of information. Or I could just put actual size as actual size will, yeah. So before the function starts, I have to carry up the actual size of the array by 1. Actual size plus plus. That will now allow me to make an extra space inside the area structures called actual size. So the number that starts off, which will be like, okay, we have 11 records. Now we're going to have 12 records. And the 12th record is going to be whatever I put inside here. And technically, I should be able to test it. So the same test here, I'm going to take the same test I had before, printf the file as read. I'll take the first ID and the second ID, right? So the reason I have this watch is because as soon as I finish do this, I want to print out what the first record is and what the last record is, and see if my new record got in. So technically what's happening is my logic is this. First thing I have to do is I have to carry up the actual size by 1, means I create a new space, a new structure in the area structures for a patient. After I create that space for that new patient, then I read all the information in from the user. The user puts in all the information, and then I print out the first and last record of the array. So instead of C minus 1, I'll print out actual size minus 1. So we'll see if that works. I think logically it should work, but I'm not 100% sure, because whenever I have to do these minus 1s, I get a little confused with the array size, and that will happen to you too. The array size will be always started from 0 to the last value, but your counter might go past the last value, so you have to minus 1. So we'll see how it runs. So I could run it and see, and then figure it out, right? So let's try to go and replace in the main, this thing, the option chosen was 1. So I'll put a \n here, and we call the actual size function. No, not actual size, add patient function. Yeah. Right. So the add patient function shall get called when I choose option 1, and it shall allow me to put in the information and then tell me if I filled it out. So just for reference, the file has 78 as the first ID and then 490 as the second, right? So let's see what will happen here. Do I get any errors first of all? No errors, right? Okay, so let's go into it and see what will happen. So enter the 4-digit passcode 1111. What do I want to add a patient? The option monochildren, please enter the new patient information. All right, good. So I'll put patient 888, surname Charles, first name Jeremy, age 45, status 1. So it prints out the first ID is 78 and the last ID is 490. Yeah, alright, well then I make a mistake because I wasn't supposed to do C minus 1. I should have done just I should just have actual size, not actual size minus 1. Yeah, alright. Let's try again. Add patient 888, Charles, Jeremy, he's 45 and his status is 1. Right, last ID is 888, good. Alright, so that means that the information has been put into the file, into the structure, sorry, not the file, into the structure. So that's good. Because now you can see the file here. The file, actually, while looking at the file there, the file, if I want to look at the file, I can look at the file here. Where's the file? Patience. One tab. Right. Yeah. So the file here is 78 and 490. Cool. Okay. So that function works. I've added a patient to the structure. Cool. No issues there. Add patient to the structure. To the array of structures. Alright, so that's one function down. That's no problem. Now, one time, as soon as I'm able to do this, I'll just be like, cool, this function works. We don't have to touch this anymore. I'll just put add function to the structure. This function works. Where is it? Right. What I normally do is you put a comment, function works, and you put the date. Today's when? Yeah. Date. Let's say it's date. This is the 30th of December 2022. And then you can put something like do not touch. That's kind of one other programmers like, listen, it is working. Please don't touch it. Don't get me and don't make it hard for me. What I want to do is I want to try now to I want to add in a function called update patients file, because if I do one action on the code, I want to be able to update the patients file after, so that this text file will now be updated with the new person that I put in, right? So the update patients file is simple. All you have to do is print all the contents of the array of structures to the file. How am I doing that? I think I have that in the pseudocode. Where's update patients here? So we had to create our output file. We had to open the text file now in write mode and output it. Okay, so let's try. So every file function that we do, we want to be able to update the file once you leave the program. That's the whole point. If you leave the program, all the changes that you made should go to the file. So we'll do update patients file and we make this a function too, because it's not going to do anything. Update patients file. Right, update patients. And now let's try to build it out. Update patient file. We had to open the file. File. Out. Well, we're naming it out. What did I name the file here? When I read all the data, I named it in. Yeah, so I'll just name it out. Yeah, because it only matters inside this function. So file out, fopen, patients.txt, but this time I'm opening it in write mode. Write mode will overwrite every single thing in the every single thing will be overwritten and the new file will be updated. So what I want to do, I want to say while what is the size of my array while to create a variable int c. Alright, just remember once you create a function, inside the function it doesn't matter, you could use over variables anytime because that function only exists inside there. So while c is less than actual data, actual size, we want to write over everything. Why are you doing that? Yeah, indentations sometimes is try too hard to, be smart. Do I have any rights to files? Well, no, boy. That means I like, I could do this. I could take this and change this to fprintf. I guess, yeah. Yeah, I could use those. Okay, so I'll go and copy and paste again. Remember, I warned you all about copy and pasting, eh? If I get error, it's just to prove to you that, yeah, you'll probably get error. So this is me now going to be very lazy, and I'm going to paste these fscanfs and literally try to change them to fprintfs. Oh. I guess they will all go one after the other. Add a pass space after each one. Okay, so that's how to replace this fscanf in with fprintf. fprintf, open brackets, out. Alright. So I'm going to take you and replace you with that. And you with that. And then you with that. Yeah, shortcuts. Don't try this at home, kids. For printing the output file, that means this first one here had to be a \n. So to go to a new line, and then everything else supposed to have a space after. So I'll put a space here, and a space here, so the strings would line up properly, and then a space there, and then space there. Right, something about the counter not making sense. Let's see. If I put C less than actual size, I'm printing back everything else. So I'm printing from location 0 all the way down to actual size. So that'll print location 0 down, all the way to actual size, and it should update the file. I'll put C++ inside the while loop. C++, or else it won't increment properly. Alright, so that's update patience. So what I want to do is every time I exit the program, I'll call the update patience file. So I'll call the update patience function, sorry. Update patience. I'm not 100% confident in what will happen here, but that's okay. Oh, then I'll do fclose. When I finish it, I'll do fclose, brackets out. Right, so I close that file. Did I do fclose when I scan the file? No, I didn't. Oh wow. Fclose in right. Alright, this is going to be wild, but there's an element of debugging that has to take place, so let's see what will happen. Enter passcode 1111. Add a patient 1. Oh gosh, I didn't neaten this up. I should neaten this up. Anyhow, 777 is the patient number. Smart, and then Bob. His age is 33, and his status is 1. Okay, press 0 to exit. Thank you for using your program. Now the test is going to be if I go to this patient's file, does it add Bob to it? No. And worse yet, it prints out the first value is empty, and it printing out also the memory values. Eek. What did I do wrong? Okay. Always keep a text file with your data decided, so you can just copy back over because you don't want to have to type this over. Alright. Always see. Oh, I put unsigned. The unsigned still there for the printers. Yeah. We're not supposed to print the unsigned, so let's print this. No, add patient supposed to have the unsigned, my bad. Is the update patient's file not supposed to have the unsigned, because when you put the unsigned, you're printing the memory addresses. Okay. C is equal to 0 once we have an actual size, it should print, okay. I try again. 1111. Right, so I want to update a patient, and I'm going to put the choice as 777 Bob Smart 53 1. Exit program. Thank you for using program. Let's go and see what the file has in it now. It prints out. The first record is empty for some reason, or because I have a \n for the printout, which is not what I'm supposed to do. And I'm printing out 0, 0, 0 each time. Let's figure that out. Okay, so I'll put the \n at the end. Right. And I'm not 100% sure if it's scanning properly. Where did I do the add patient? Okay. Oh, okay. All right. So when you're scanning a string, you don't have to put the unsigned. That's usually give an error. In the older versions of C, you could do that, but when you're scanning a string, you just don't put the unsigned. Okay. All right. That was one problem we found there. Let's see if that fixes it. 1111. Add patient. Please enter the patient information. 777 Bob Small 33 1 0 to exit. Let's see if our file updated. It's just getting filled up with a bunch of zeros. And that is because I am not smart. Because it is saying the first ID is 78 and the last ID is 77, which is correct. I think it's actual size +1. Yeah, it might be actual size +1. Are you tracking? Believe it's actual size +1 with the issue. 1111. Patient 777. Bob Small 33 +1. Alright, press 0 to exit. Did it update the patient's file? Yes, it did. But it have also the zeros in between. I feel the actual size messing up. Okay. There's only one way to test it. Alright, so we restore the file to its actual stage. Let's run it again. 1111. Add patient 777. Bob Small 33 1 0 exit. See what we get. Right, cool. It works. I give him extra space. Why is it giving me extra space? This blank record here, that will make life easy because it's not supposed to go to the next line. It going to the next line basically means that I have a problem when I do the fprintf. I'm printing out to the next line. Don't want to do that. Don't put the backslash in. That way it will just put the things in spaces. And in next record, how will it know to go to the next line for the new record? Actually, no, I will put the backslash in. Alright, so let's test it now and see if I can put in 2 new people. That way I know that it's working properly. So right now we did that. Right, so we're going to try a quick test here to see if I can put in 2 new people and the file will update correctly. So let's go. Passcode. Please do tell me my power set. I want somewhere in the code here. Okay, no, I didn't. Alright, 1111. 1111. Right. Add patient. 777. Bob. Small. Age 33. ID 1. Cool. Choose option 1. Add another patient. 888. Something 23. That was 2. 0 to exit. Alright, let's see if our 2 new patients have been added. Yep. Nice. Okay, good. So it's writing properly, and the new line basically puts the new record to go here. So that's okay. It will have that new line there, but it wouldn't have anything to read from it when you read from the file the second time. Alright, so that's our add patient function working. The add patient function is working and updating the file is working. That is very, very important because now we have proven that we could open a file in write mode and we could also open a file in read mode. So we open a file in read mode, we read all the data, and then we could open a file in write mode. So that's cool. Good. Cool. That's 2 functions done there. Oh, I didn't think it would take so long. Actually, I took so long on those functions because we didn't do the update. We didn't do the update patients file. So this update patients here down at the bottom, this here will run whatever you do in the code, whatever you do in the program, it will do all of that. And when you leave the program, it will update the patients. Now, of course, you could create a function to update the patients, but those are things that we could do in Unit 2 to make this program a lot better. Right now, we're leaving the program slightly dumb. And some of you all may be watching and be like, but you could do this and you could do that and you could do this and you could do that. Yeah, but we don't really have that much time in Unit 1 to make your program super efficient. All you want to do is have a high level of efficiency where it's broken down into different pieces, where you don't want to try to keep adding blocks to it until you finish your code. Because you have to finish this code, then we have to test it and whatnot. So we could do a whole set of different things with the update patients, ask, do you want to save this change and update patients and all kind of thing? But we don't have time. We don't have time. So focus on your task. So we just got one major function done, which is the add patient. And this function here, it doesn't really have much if or conditional logic in it, but actually shows that you understand this variable called actual size and using it properly to be able to test your stuff, right? So good. So this test here, I could comment this out because we could come back and deal with that. Now we're going to try and update a patient, right? So to update a patient, this is where you're going to try to create a function that will do some sort of receiving of arguments. So we make the void function still because it's not going to return anything. Update patient. Yeah. But we want to receive the ID of the patient that we want to update. So int ID. That way, the person who is calling the function could update it. they'll get a prompt in the main when they choose update patient. When they choose option 2 here, please enter the ID of the patient you want to update, and then it'll send that ID to the patient. Now we could read the ID inside the function, but remember we want to prove to the examiner we know how to do functions in different ways. So in this case, we have a void function here that's not receiving any arguments, and now we do a void function that is receiving an argument. When we go to the search, we'll do a void function we'll do an int function that receives an argument and sends back a result, because you want to show that you could do all the different function skills. So update patient, void function, ID, right? Good. So we want to update the patient. Essentially what we want to do is search for the person. Search for that particular ID. And before we do the update patient, it'll be wise for us to do the search function. I'll tell you why after, right? So let's do the search function. Int search patient. We want to get because the array is declared global, we do have to send the array. So that's okay. We want to get int size and int search ID. No, why do I want to do that search function? Oh, because I need to get the index right here. So this search patient will get the ID and return the index it is located at. Yeah. Right, so we have that in place. Now, what do we want to do? We want to create a for loop to go, oh, we don't need to get the size, because we know the size already. We know the sizes are the actual size. So all we're going to do is get the search ID. Okay. So we will put we have to create a counter. This is a linear search, by the way. Linear searches are very basic searches. Let's go through all the records. For C is equal to 0, C less than actual size. It should be C less than actual size plus 1. I cannot remember. What did we have to do when we had to update the patients? We had to put C less than actual size plus 1. Yeah. Alright, so I'll put in C less than actual size plus 1. I could probably fix that by yeah, we could probably fix that by taking the actual size here and incrementing it at the end, So that way we'll just have to use actual size alone. Should I try to fix that now? Or should I not try to fix that now? Logically speaking, if I increment the actual size at the end of the add patient, it will do it correctly, because I wouldn't have to put actual size as C minus 1. I'll just put actual size as C. Alright, that's all. Let me test this. Test this in here. I'm going to put the actual size as C, so that I don't have to do actual size plus 1 in the print, and I'll carry up the actual size by 1 when I finish here. And we'll carry up the actual size here. look at just, and I actually put this function works, do not touch it, but I want to make it more efficient because I don't want to have to deal with that -1 all the time, every time, in every single function. So if I put the actual size is C here, the actual size will go up by 1 once I put in an actual value. Nope, but I'll have to put the actual size plus at the start. No, the actual size will be the place as okay, let me carry actual size here. Yeah, this will get confusing a lot for students, but that's okay. But we understand it now. You know, I'll do when I read the data. Nope, I'm going to leave it as is. I really don't need to fight that down right now. It working? It working. Alright, so we'll go actual size +1 and then C++. If it's not working, then I could just go and I'll do the actual size -1 after if I feel like it, right? If it's not working, but I don't need to fight down the efficiency that much right now. Yeah, so you remember I just said I would be lazy and leave the actual size as -1. I think I decided I need to do it properly, or else we would end up into big problems. So I kind of just cut for a second there, and I went and fix the actual size problem, because that's a problem that you will have all the way through. So this is me proving to you that you should think it through every single time, or else you'll end up in big problems. Sorry to interrupt the video, but this is future me talking to you while you're watching this. And if you are struggling with a certain part of the IA, or you just need some way to check over your IA, we do personal one-on-one IA classes. So if you want your IA to get a check over, just to make sure you have all the requirements on the marks, makeITsimpleTT.com/register. Okay, cool. Back to the video. So I'm gonna show you what I had to do. Technically, what happens is when we do the read data, we read from the patient's file, and the patient's file will have some information in it. I think the patient's file I had up to here, right? Good. So what happens is this patient file will start off at location 0. I really start from 0. So imagine if I have 10 records. I'll be dealing with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But it's actually going to be 10 indexes, or 10 actual locations. So those 10 indexes would be the 10 values that I have, but they're really numbered 0 to 9. So what I'm doing is I created a variable called actual size to keep track of what the size of the data set is. That means if I have 10 things, I'll put the number as 10. But when I go to my loops now, I'll have to put less than actual size, less than 10, because I want to go 0 to 9. So if I keep this actual size correct, that actual size will actually be able to tell me at any point in time how many records I have actually in the hospital, or how many people. But I have to keep in mind that the actual indexes will be 1 less of that. So there are times when I'll have to use actual size -1. But it's a lot easier for me to just set the C to actual size here when I read from the file. So now whenever I have to do a loop, all I have to do is C less than actual size. Because all my while loops, all my for loops will just be counting up to the end of the array, which is actual size -1. So that's going to save me a lot of headache. So that's why I set an actual size to C. Now because we set actual size to C, when we go into the add patient function, I have to do something very important. When you're printing, when you read from the user, right, and you read the ID, the name and first name and age and whatnot, this actual size here is not the actual number of elements I have. This is the index. So I have two options. I can either put actual size -1 inside here, or I could just put the actual size, which will put it at index location 10, In other words, making the array have 11 values now. Yeah, making the array have 11 values. But the 11 values are really 0 to 10. So once I do that, that means I have 11 values, then I'll have to carry up the actual size by 1, because this actual size is supposed to keep track of every set of records that I have. So if I add a new record, I use an actual size here in terms of index. And then this actual size here is the actual number of values. So instead of putting -1, -1, -1 inside, I'll just put it inside there, using it as an index value instead. And then out here, this is the actual value of the amount of data that I have. And that's the thing you bounce up when they deal with indexes and deal with indexes and actual values. So just remember, this actual size here is the index, and this one here is the actual value. That'll save you a lot of headache, especially if you're doing a database kind of driven IA. You'll have to keep that in mind for your structures, right? For your array of structures. So now this add patient function is updated and fixed. This function works. Now I can actually put the do not touch, because I know it's working, I know it's going to put it in the correct place, and the actual size will go up by 1. And the reason I'm printing out here actual size -1 is because this is an index here. Once it's in the bracket, I'm dealing with an index, not the actual amount of records. So good, so we fixed that. The add patient is sorted out, so I fixed that problem. Now I could go on to deal with the search, which is, if I do a search, I could use the search ID and put in all the information, and I could just use actual size, because actual size here is not an index value. Actual size here is a record size value, and the search ID will return the ID and will return -1. And the update patients, all the update patients will stay the same, because I'll just check while see if that's an actual size, because this is not the index, this is the size of the records. Keep that in mind, and that should solve all of our problems there, right? So now that I've fixed the actual sizing and indexing issue, the rest of the function should be really easy, because it'll just be a bunch of for loops and while loops that use actual size to do something. So yeah, let's look at the search patient here. So search patient data, right? So search. We're asking the user to enter who they want to search for. So we put the if inside there. We ask it if the index is -1, print the patient was not found, or print the patient was found at that particular location. So we have done option 3, which is the search function, and we have the add patient. Now that I have the search function in place, I could move on to a next function that's pretty simple to do, which is the function, not remove patient. Remove patient will take some work. Update patient will take some work also. I could print the info, print patient info to the screen, because now I could call the search function, get index, and then print out all the information. And it's pretty easy, right? So this one is a void function, because it's going to just print info to the screen. So I'll void, it needs to get index. Yeah. So it's going to get an index. All it's going to get is a value. We're just going to be like, okay, cool, that's the value. Sure, no problem. Alright, so here's the void function. To void print info. Alright. So to print info, all I need to do is just use this same index here and print out all of the stuff. So I'm going to steal all the print information from here. Where is it? Where do you want to print to the file? Yeah, taking all the fprintf here. Yeah. And instead of using the fprintf, I'll just go and use the printf version of it. Again, copying and pasting is at your own risk. I just warn you, this could backfire on you real bad and create a whole set of errors that you probably didn't want. But that's okay. Alright, so I just want to printf the %d, so that's printf that. Taking out the output file part of it. Nice. So what this will do is it'll print it out to the screen, and I'll see all the patient information. But I probably want to put some information like ID, first name, no, the surname, first name, age, and this is status. Okay. But I'm not printing C, I printed index. Yeah, index is what I need to put inside it because I already called the search function, and the search function is going to send the index that I've currently gotten back. I can't see what I'm doing. Oh. Dark mode is nice when it's until it's not nice. Yeah. Alright, so now I have void print info, which is expecting the index, so now I could go to option number 5. So we update option number 5 here. And we will take the index that we got. Print info. Print info. We send in indexed it. Now how do I know which index I am going to use? I am going to call the search function first. Is equal to search. I'm basically going to take this same line here, index is equal to search patient, and whatever index I get, I will print out this stuff. Yeah. Now it's kind of inefficient because we have a search that just telling you if a patient exists or not. But this one will just tell you if the patient was found or patient was not found. If it does tell you that it's found, then of course, then you can do the search index and put any patient info if you want. It's not exactly efficient, but remember, our goal here is not to make the program super duper efficient, because there will always be things that you can get better. Our goal here is to get it to an acceptable standard where it works and it achieves the functional requirements and get the marks. In Unit 2, we'll make some of these things more efficient and it will look a lot smarter. Alright, so let's see if it will print the info out. There are a lot of errors. A lot of errors with the print info. Where is it? Oh. No. What did I do wrong? Oh, the square brackets. I missed some square brackets, right? That's real weird. See? Okay, yeah. One square bracket caused all of those errors, you know. That's crazy, yeah? Watch this. Program working here, right? I'm going to stop it. One square bracket. Take that out. And look, about 5 different errors come up. Feel free if that happen. Alright, so we're going to run the program now. I know all the other functions are working, so let's see if I can do the search function. Please enter the passcode, 11. Right, so now let me search for a patient first and see if the patient does exist. So I press 3 to search for patient. I'm looking for patient number 78. Yes, that patient does exist at location 0. Okay, cool. So now let's go to print patient to the screen, which will be number 5. Number 5 should call the search, and it should put Sheldon Cooper. Oh no, it wasn't supposed to do that. Wasn't supposed to do that. What it was supposed to do. Please tell me this didn't do that. Yeah. What it was supposed to do is that it was supposed to call the search function before I do it. Yeah. Oh, my bad. Yeah, so all of the stuff that I did here, which is scanf, please enter the patient you want to search for. Yeah, I'll put that there too. Of course, clearly, yeah. Right, please enter the patient ID you would like to search for. Print the info. Okay. Again, it's not efficient, but that's okay. I'm just displaying my skills. 1, 1, 1, 1. Let me just jump straight to print a patient record one time. I want to print patient record 78. And it should print out first name, ID 70, right? Good, yeah. Sheldon Cooper. Yeah, the only thing is it's not very neat right now, so I'll do some neatening up in the function. So I'll neaten it up by putting some \n after each one. So \n, \n. I'm putting it at the start because that will ensure that it will always space itself out, no matter what came before. Whenever you do a printout, just do a \n one time. Yeah. Enter the patient you like to search for. Colon space. Enter the space I like to search for. Colon space. Right. But in this option, I want to put enter the patient ID you would like to display. Right, that would make more sense. Yeah. Okay, so let's try it again, see if it works. Let's see a new number. Let's try patient 223. I should get Steve Jobs. Please enter the 4-digit passcode. 111. Search for patient is 5. Patient you want to search for 233. Yeah. Okay. Alright, so I know what you're probably saying is like, well, the search patient function and the display patient to the screen function, they could be put into one. Yeah, they could. But I don't want to make the program perfect right now. I want to make sure that I have a wide array of functions that display the skills that you're able to use, and it's broken down logically. So you could just search for a patient and say, well, the patient was found, and that's quite all right, because not every time you want to print out the information. So good. So much functions we have there. I think if you just have this alone, you have a wide range of functions that will get you the marks. If you want to stop here and just call this a basic program, you don't have to do the update patient or remove patient. So we printing them to the screen, we could search for one or whatnot. The only thing that I would recommend that we do is the print the critical patients. So let's do the print the critical patients one time, and then we'll work on the update and remove after. Because the update and remove, they could take some doing, depending on the issues that you have. But so far, we can add a patient. Okay, before we jump to that, let's test one important thing, which is if I add a new patient, would I be able to search for that patient? So let's try that. Let's try to add a new patient, 1. Enter the patient information. Patient number is 111. It's Jenny Craig. And the age is 33 and the ID is 2. Okay, cool. Now if I search for 5 Jenny Craig, which is 111, do I get her? Or add somebody else that was 111? That's real tough. Okay. Ha 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 ha. I didn't realize that 2 people else had a 111 already. Just SpongeBob it. Shouldn't have done that. Okay, let's search for, let's add a new patient that's 5555. 5. Patient. 1. Add a patient. 5555. Billy. Idol. 55. 2. Alright, so now let's search for patient 5555. 5555. Billy Idol does exist. When I press 0 to exit, it should update the file with all of that information. Did it update? Yes, there's a second 1111. Yeah. That's a problem. But in a database, you're not supposed to be able to do that. But point is, so far our program is fully functional. And we bounced up some errors, but that's the whole point of me doing this. I want to show you the whole process of finding the errors, making sense of it, understanding why certain things are happening and all that. So every function is doing what it's supposed to do. I'm quite happy with it. It is able to search and tell me if somebody does exist. It's able to search and display the record by calling the search function and then taking the value from the search function and putting it. You see this part here where you could call a function, take the output from that function and put it into the input of another function. That's gold. When an examiner see that, they're saying to themselves, yeah, that child know what they're doing. That child know what they're doing. Okay? So let's go to option number 6 now. Yeah, let's go to option number 6. I'll probably have to do a next video after this just to show you how to clean up the code and then paste it into thing. Clean up the code to make sure it's user friendly, put some clear screens in and all that kind of stuff. I'll probably do that in the next video. So I was only planning to do 2 programming videos, but now I have to do a 3rd one because cleaning up the code and making it user friendly and whatnot, that's something that we want to do. Alright, let's do the last three functions and the last 3 functions and call that a day. Alright, this next function is to print out critical patients. Okay. So this function, all it wants to do is to find out everybody that's critical. So once your status is 3, it should print you out. I think I have that done already somewhere here. Do I have it? Print critical intensive care, yeah. Alright. I'm just going to copy this and explain it here. Well, update it so you can see. Print critical patients. Okay. So this is a linear search that we're going to search through, but their status must be equal to 3. So I'm going to open my file called care, because the critical patients have to go in intensive care. So I'm going to call the function intensive care file. I'm going to open a file called care fopen intensive care.txt in write mode. And we create a variable called c to count. But I'm going to say for c is equal to 0, for less than actual size, because now I know the actual size is that number. And then if P location C, the status is equal to 3, then obviously I'm going to print that person to the intensive care file, which will be the patients that go in intensive care. And I'll now put a message at the end that will say the critical patients file is ready to print. Okay, so watch it again. I want to print the critical patients, so I'm going to create a function called intensive care file. I'm going to open the file care in write mode, intensive care.txt. Now it doesn't matter if that text file exists in the IDE right now. It will create the ID. It will create the text file for itself. So first use as an actual size C++, add up, and then print critical patients. So technically, I should end up getting a file here that's named, instead of just having patients.txt, intensive care will get created if I choose option 6. So let's run it again. So watch what happens on the left hand side here, and watch what happens on the right hand side here, right? So I'm going to put in passcode. And all I want to do is just print the list of critical patients to the file, which I can't do because I did not call the function in the I didn't call the function in the main. My bad. Yeah, so in the main here, where it has option 6 was chosen, yeah, I have to put it on. Intensive care. Right. So now when they choose option 6, it will just call the function for intensive care. Intensive care will run what it's supposed to do on there. So let's do that again. Pay attention to the left hand side here. Main.c and then patient.txt. Pay attention to here. So I'm going to put in the passcode and I'm going to run 6, which is just 6 of them. So all I want to do is take all the information from the text file and did I name it patients.txt? I hope so. Let me double check. Yeah, patients.txt. Okay, cool. So we run 6, and watch what happens on the left hand side. Intensive care exists now, and now if I go in intensive care, it should show me the names of everybody who is in intensive care. But it gives me a space at the start. I don't like that space coming up at the start. Okay, let's figure out why I give me that space at the start. That's why we call that our \n. Yeah, this \n should not go there. Oh no, that's update patients file. Sorry, that should go there. This one here, where is it? Intensive care file, upper \n at the start and a space. So that means it goes to a new line and then starts to print the information. I don't want that to happen. I want it to print the information, then go to a new line. Yeah. Alright, so let's delete all this stuff from the intensive care file. I'm just going to prove it again, right? So I'll go and delete the whole intensive care file that's here. Let's just go and remove it. Delete. Yes. Right. Why is the patient's file having a space at the start again? I cannot remember. Patient's file is not supposed to do that. I'll run again and see what happening here. We go with 6. Should filter out the intensive care file exists. I press 0, I exit, and the intensive care file should have all the names and then a space at the end. Okay. Patient's file It's doing that again. Those backslash n's get me mad. Let's go and fix them one time before I get vexed. Alright, the backslash n's causing a problem because whenever it prints to the file, it's going to create a space at the top. So I have a problem where when I update the patient's file, it's going to reprint. It's going to print a value to the end. So here's what I'll do. I will leave this as is, pass space after it. So I'll put the spaces after. This is actually fine-tuning stuff, right? Because functionality working, right? But so I'm gonna put the spaces after I print all this stuff. So I'll put a space here, then a space there, then a space there. Then no space after the last one. What I will do is when I finish everything, no, I have to put a backslash n somewhere for it to go to a new line. Where do I put the backslash n? At the start or at the end? I'm going to have to put it at the start. I mean, it doesn't matter if the file starts. Yeah, we'll leave it as is. The backslash is not going to really hurt anybody. Another problem for another day. With the backslash and we put the spaces, the last one will have no space at the end, and when it loops over, it will do a backslash n, and it will print it out. Okay. Same thing for this one here. It'll put a backslash n at the start, and then all the information will go. Yeah. Okay. I guess that's a problem that we had a little bit. The problem that I have is that the space that happens at the top, there's a space that comes up here. The first line gets empty, but none of the records getting like affected because the actual first value is here. So it's not seeing this as the first value unless I have to read that character. But all right, good. You see how easy it is to get sidetracked, right? We don't want to get sidetracked, right? Last two functions, as I said, so far this program is it's serious. This program not looking bad at all. But we want to be able to update a patient and we want to be able to remove a patient. Now this is where you have like a problem where you have to deal with. You have to ask yourself, do I need to add more to this to get the marks? Most likely a teacher will tell you yes, and tell you you have to be able to add the patient and remove the patient and do it. But if you really check it out, all the skills that are necessary to be able to get the marks in Unit 1, you've already shown. You've already shown that you are able to manipulate files. You've already shown that you're able to create functions that will read and return. You already showed that you could create functions that could open files and print them out. You already showed that you could manipulate global variables. You've already shown that you can search for ID by using a for loop and return a value based on what you find. You've already shown that you could create a function that will receive an integer or receive a variable and do something with it. You've already shown that you could receive something and not send it back. You've already shown that you could not receive anything but open a file, search for something, print it out, and print it out to a file. All of that falls under these things here. It's broken down as independent units. So that is at least 5 out of the 6 there so far. But I just want to make sure that you get all your marks, right? So depending on if the examiner is a very, very, very critical examiner, they will want to see that you could be able to update the file and update a patient and remove a patient, right? So to update a patient, we're going to have to first start by searching for the patient that we want to update, right? So we'll call the search function and we'll ask printf, please enter the patient ID you would like to update. And we'll read it in. And then we'll read that ID, right? Print scanf. %D. And we're reading that into an ID, right? Now, this ID here is the ID that we're going to have inside this function. So we just create an int ID. Set it to 0 to save your trouble. All right, once we know the ID that we want to search for, we're going to have to get the search function in play now. So we have to call the search function. Call search. We have to create an index also. Index equals 0. Right, so we'll say index is equal to search for that particular ID. And once we get the index, we will now say, okay, please enter, no, printf, sorry. Please enter the updates you want to make. Right. You could make this here as complicated as you want, and you could update all kind of different things. But I'm just going to update the name, right? Yeah. Now I'm just going to update the status. Please enter the patient ID you would like to update. Please enter the status. In this case, all I want to do is update patient status. So I'm going to name it update patient status. Because you could change the name, you could change their ID, you could change their age, all sorts of things you could change. But remember, we just proven that we could do certain things. Because once they could do this, of course, you could do a next one that could update their name and status and all that. So please enter the status update you want to make. And we will change their status to scanf. And we're scanning it straight into their variable %D. And we're going to change their status to and p location index dot status. Yeah. Start. Yeah. So we're going to update the status of the person that was searched that we got the index for and put it inside. I mean, this by default it's looking complicated. That's because it's a little complicated, because you need to understand that you're calling a search function, getting the index, then taking that index and using it to update the status so that the status will update for that particular patient. And in order to test it, you're going to have to call back the print for that particular patient. So we could call the we have a function that doing that, and we could print the patient info to the screen. Yeah. So we'll just do print info and put index. So I'll call back the print info. Print. Yeah. Right. So this should prove to us that we actually updated that particular patient status by doing that. as I said, this type of function is do a lot more than you expect, but that's okay. The remove one is the one that has caused the problems. But you don't have to do a remove function, but you should be able to do an update function. Because right now we added records, we could search for records, we could print out records, we print into files. There's so many things that we're doing that your marks are almost secure. You don't need to like fight down these bigger functions. But if you want to ensure your marks are booked, yeah, you want to get to be able to update and you want to be able to remove. Because I've seen children get the full marks for their IA without having to put the update and remove. But just make sure, as I said in the previous videos, your functions have to be complex. Not complex in terms of a lot of calculations, but your functions must utilize all the different skills. Reading from file, getting values, passing values, returning arguments, all that stuff. You want to show that, and that's where you're going to argue for in your documentation when you show that, hey, I did this. I understand what I did, right? So let's see the update patient status working. Do I have errors? Yes, I have errors. Line 101. Oh, I can use ID. Yeah. Alpha ID X. Oh no. This update patient status don't need to get the ID because it's asking for it inside here. Alright, so we don't need to pass anything to the update patient because it will ask me one time inside there. Line 128. What did I do on line 128? Conflicting types for int info. Void print info. Print index. What? Print 109. Oh, alright, so I named it index inside here, but I can't send the word index to the print info function called index because it will be like, you can't use the word index twice, it doesn't know which one is one and which. So I'll add the name as IDX. Yeah. Alright, so IDX should fix that there, IDX should fix that there. Alright, the reason I have to use IDX is because when I call the print info function, I can't use the word index because print info function already has a variable declared as index inside there. So it'll be like, what's your real name? We don't know who you really are. So IDX should fix that. Did I do it again? Is it somewhere? Line 128. It's seen on line 109. Oh, the function is below print info. Yeah. Alright. Yeah, my actual issue is I didn't prototype all the functions because I don't like to prototype functions. Alright. Let me prototype all the functions. That means I had to list all the functions, no, because functions jumping between functions causing problems. Because once a function not on top of the other function, it doesn't know when it does exist now. Prototyping all the functions. Prototyping all the functions just means copy the function declaration and pass semicolon after it. So we have int password. Yeah, we are in password. We have void read data. yeah, at some point in time, just go in your code and prototype all the functions, especially if you're calling functions within functions. Yeah, should do that. Because they won't be able to see each other if they're on top of each other or below each other. So I actually don't think the index one was a problem. Wait, there's real functions here, boy. In the old syllabus, they used to tell you only need 5 functions, huh? But alright, so let's go and prototype all of them. Let's go and paste each one of them one after the other. The reason we had to prototype them is because they can't see each other. Let's go, starting with password, semicolon, enter. After password, we have read data. Then we have welcome, semicolon, enter. Then after welcome, we have menu, semicolon, enter. After menu, we have add patient, semicolon, enter. Then print info. Then intensive care. What intensive care is here? Oh wait, I miss a few. After add patient, I had update patient status. After update patient status, we have that's all? That's not all. Search patient. After search patient, we have print info, then intensive care file, right? Then update patients. Just normal update patients file. This one is update patients file. And then the last one is mean, right? Okay. Right, the reason we have to list out all of these functions is so that the code will know how to jump between functions and know that they exist. Because right now they didn't know that they exist. What did I do? What is the actual issue? In function update patient status, and if I reference to search. Let's see what's the problem with update patient status now that you prototype them. Oh, did I name it search? It's supposed to be search for patient. Search patient, yeah, my bad. Yeah, my UC here was search patient. Alright. Will you run now? Alright, now you're going to run. Okay, so what we're going to try to do, update a patient. Okay, let me see this text file. Text file, alright, so let's say we want to update Sheldon Cooper from status 1 to 3. So we're looking for patient ID 78 and we're changing the status to 3. Okay, 1111. Update patient, which one is update patient 2? Oh no, I didn't put the update patient I didn't actually call update patient status in the option 2. Yeah. Here, main, option 2. Right, so I'm going to call update patient status. No, update patient. That's it. Update patient status. I should name the other one update patient's file. Yeah, we'll fix that after. And we'll just see if it's working. Alright, so we zoom in here. Alright, so we want to update patient, which is patient number 2. Enter the patient ID you'd like to update, 78. What is the new status? The status will be 3. And status is 3. It prints out the information. Press here to exit. Now when I go back to the file, Sheldon Cooper should no longer be at status 1. He is at 3. Yes. Alright. Cool. Yeah, for time purposes, I'm not going to show you all how to do the remove a patient. Like, because to do the remove a patient, you have to remove the patient, and then you have to do a for loop to put every ID back down 1. From the location that you are at. Yeah, I'll leave out the remove patient because we have enough here. Remove patient, I'll probably do in unit 2. So this is a prime example of you've done enough. You've done everything that you need to do. You show all the skills, you have everything working, but you don't have it in here to write that next piece of code to do the remove patient, because for remove patient, I'm going to have to find the patient, put everything to 0 from that particular index, and then do a for loop to shift everything down, to shift every structure down from that index, go down. And that's something a teacher could do with you if you want, but I'm not doing that right now. If you want, you could skip to all the unit 2 videos, and most likely I'll do the remove patient function inside there. But here's what I want to show you. I want to show you beyond a shadow of a doubt that you have all of the things that you need in your code. So watch. According to the structure decomposition of functions, let's go to the list of functions that we have, because the prototyping does help with that. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 functions. Well, the main is not a function. Don't count the main, right? So we have 10 functions. In those 10 functions, we should have some that read our file. Yes, we have one that reads from our file. We should have some that prints our file. We have 2 that prints our file. We have printing the status to one file, and we have printing the whole file out to the file. So we have 2 output files coming out there. As marks there already, right? You should have the ability to search for some data. Do we have the search? Yes, we have the search patient. You should have the ability to search for something and print it to the screen. We have print info. Yeah, cool. Then you should have the ability to update a record. So we update the records there. That is 5 marks there. And then you should have the ability to add a new record, which is that is 6 marks there. So we have file manipulation, we have search for records, we have add records, we have update records. The only thing we don't have is the remove. But in this case here, according to the mark scheme, we have everything that we want to do. Right, the remove function, you could use that as a, well, we'll give you the ability to remove in version 2.0. But that gives us all the things that we need. So now this code here is complete, and complete for unit 1. So all we have to do now is comment it through and neaten up the outputs so that the output looks all neater. So we'll go through some clear screens, we'll go through some indentations, we'll probably try to put things at the center of the screen, things like that to give it a little user interface, a better user interface. But we don't have to worry too much about user interface because there's no mark for user interface inside unit 1. In unit 2, there's user interface. So what we're just going to do, we're just going to put in a lot of \n's to separate the to separate the output so that it doesn't look as jumbled as this, because that's very jumbled. The only reason I left it this jumbled is because we understand what is taking place here. Remember the user can't, like, you know, see that press 0 to exit and then you see a 2 right after the option chosen was 2. All of that, we hadn't eaten up all that code. But your first goal is to get functionality. Once you got that functionality, you're good to go. So we will pause here, and in the next video, we'll neaten it up, we'll clean it up, and then we'll reverse engineer the functions to match the pseudocode and take out the things that we couldn't do, because that's a very likely possibility. You might aim for a lot of functional requirements, and then you might like decide, all right, I can't do that one, but I've done something else in its place that will be able to get the marks, and then we'll be able to say, okay, we have all these 19 marks here, because all these 19 marks contain in that code there. We just need to document certain stuff, and then we'll go on to the testing and presentation, which shouldn't be that bad.